For number 10, then just a reminder that the circumcenter has to do with the perpendicular bisector. The orthocenter has to do with the altitude. The incenter has to do with the angle bisector. This is really messy, huh? And then the centroid has to do with the median. That's a lot of lines. Either way, Mo contains all of those. Okay. Then for this one, for number 11, the range of possible values for x. Notice these are not angles, they're just sides. And since this one is big and this one is small, then we know that this one has to be the bigger one and this one also has to be the smaller one. So we have two different inequalities that we're going to have to do. One of them is 2x minus 4 has to be smaller than or less than 28, and then we solve for x. So add 4, and then 2x is less than 32, divide by 2, divide by 2. So x would have to be less than 16. That's going to fit right here. The other one is we definitely don't want this to be negative. So we want 2x minus 4 to be greater than 0. And then we add 4 again, add 4, then 2x is greater than 4, divide by 2, divide by 2, and now x would be greater than 2, which goes right here. Then on this one, it tells us that we have AH is the small one. And then it tells us that GB is the big one. So that means that this angle is big, right? Big. And that this angle right here is small. And so then the questions go with that. So then the angle that it would go with is ABH is the small. So ABH is the small. And then this one is the big one. So it fits this one right here. Okay, number 13. So we have a triangular frame. So we have, I'm going to draw the picture of this. We have two pieces. One is 18 inches and the other one is 27. And see how this is almost a triangle? If this is 27 inches, then we have two different types. We can have 18 plus 27, which would be, if we do 18 plus 27, it's 45, right? Or if they were really close, so like here's the 18 right here, and then maybe the 27 is like really close to it. That's supposed to be straight. Haha. Okay, and then so we'd have to have one that's the same thing as 27 minus 18, and we would get 8, right? I can count, I promise. So for sure we want it to be somewhere between 9 and 45. So which one of these situations is between 9 and 45? Well, this is 9 inches or less. For sure can't be less. 45 inches or more, for sure no. Between 10 and 44, yes. And it is for sure possible. So there we go. All the true statements. So we are talking about circumcenter, incenter, orthocenter, centroid. So I'm just going to draw an example. If your triangle was like this, and we were doing the circumcenter, they're perpendicular, perpendicular, and even if you just have two of them, that is outside the triangle. So that would be true. The incenter, so since you can have any triangle, would always be the angle bisectors coming to meet, then it's always going to be inside, so not true. So that would be false. Oops, that would be a false statement. The orthocenter, I'm going to do the same one that we just had. If we did, like coming out here, if we did the altitude of this one, it would have to be outside. Oops, it's supposed to be a right angle. Outside the triangle right there. And so all the other ones would have to meet out there some also. So this would have to be out. That could be out. It's not always out, but it can be. The centroid, since on a triangle, the centroid is doing the midpoint. Like those are all the midpoints to the opposite vertex. Then it's always going to be in, so it can't be that one. So I'm going to put no and no on this. And then they all can be either inside or outside. No, because the in-center always has to be inside, and the centroid always has to be inside. So no to that one. And then in this figure, if we look at the picture, I can see because we have these angle bisectors and they're perpendicular. We want the inscribed, so really that, oh yeah, so then we would make this inscribed circle right here. This circle would go right here. So that would be the inscribed circle, which would mean that XU would be the same as XW. So we would solve negative 4y plus 20 would equal 6y plus 10. And we just solve for y. So add 4y, and minus 10, minus 10. And then we would get 6 plus 4 would be 10y, and 20 minus 10 would be 10. So now if we divide by 10, we have that y would have to equal 1, and we can plug that back into either one of them. So if I did 6 times by 1 plus 10, right, because that's based on this one right here, then I would get 6 plus 10, which is 16. So 16 would be my answer. Okay, a police officer is parked at the junction of two streets, and he wants it to be equidistant from the streets, not from the points, but from the streets. So the streets would be like the equidistance, kind of like the one that we had above. So it would be like that point right there, and that point right there is all based on the angle bisectors, because it's the in-center, because it's inscribed, and then that means that it goes with the angle. Looking at our notes from above, that's the angle bisector. So, angle bisector. And that is the end of the review. Okay, so down below here, we have, I have included here all of the notes on the centers. I explained 3 through 5 in like 12 different ways. So any of them would be good that you could use. The one that I actually used for the video, was just this one right here. Yeah, so hopefully one of those helps in the review. All right, good luck.